The Russian nightmare in the hands of Ukrainian snipers and drones. Imagine a perfect shot from 4 kilometers away. A bullet cutting through the air for more than 2 minutes before hitting its target with surgical precision. And that target is a Russian soldier. Now picture that combined with kamikaze drones chasing soldiers across open fields, like a movie scene. What you're about to learn will completely change your perception of how modern military operations work, and how this has become Vladimir Putin's worst nightmare. Since February 2022, the conflict between Ukraine and Russia has completely transformed the concept of modern warfare. But it's in 2025 that we're witnessing something truly revolutionary. The deadly combination of snipers using artificial intelligence and remotely operated FPV drones is rewriting the rules of military engagement. The numbers tell an astonishing story. According to data from the Royal United Services Institute, a respected UK-based strategic studies think tank, drones are responsible for 60 to 70% of all destruction inflicted on Russian equipment in the conflict. We're not talking about a secondary or experimental tactic here. We're witnessing the main combat tool of the 21st century in action. Ukrainian forces have developed something few military experts predicted: a perfect synergy between cutting-edge technology and extreme human skill. While FPV drones, those small quadcopters packed with explosives and controlled through VR goggles, hunt down moving targets with terrifying precision, Ukrainian snipers are breaking world records by taking out targets at distances that defy imagination. On August 14, 2025, something extraordinary happened on the battlefields of Eastern Europe. A Ukrainian sniper, whose identity remains protected for operational security reasons, accomplished something that even the most skeptical military experts once thought impossible. From a distance of exactly 4,000 meters, that's the length of 40 football fields lined up end to end, this operator managed to eliminate 2 enemy soldiers with a single shot. To put that in perspective, most professional marksmen already consider a shot difficult once it goes beyond 800 meters. This Ukrainian multiplied that distance by 5. Military journalist Yuri Butasov shared the technical details of this operation that left analysts around the world speechless. The shot was made using a 14.5mm alligator rifle, a weapon designed specifically for extreme long-range engagements. But here's the most fascinating detail. This wasn't just a lucky or extremely skillful shot. It was guided by artificial intelligence. Drones were flying above the area, feeding real-time data on wind, humidity, atmospheric pressure, and target movement. AI algorithms process this data instantly, calculating the perfect trajectory and compensating for dozens of variables affecting a projectile traveling over 4 kilometers. The result was surgical. The bullet passed through a window where the targets were positioned, completing what experts now consider the longest confirmed shot in modern military history. This record surpassed the previous mark, which also belonged to Ukraine. In 2023, Vyacheslav Kowalski, a 58-year-old businessman turned volunteer sniper, had set a record with a 3,800-meter shot using the national rifle Lord of the Horizon. Ukraine not only broke its own record, but also set a new benchmark for what's technically possible in long-distance combat. To understand the magnitude of this achievement, we need to dig into the technical details that made it possible. A 4-kilometer shot isn't like shooting at a close-range target. The bullet travels through the air for about 2 minutes before hitting the mark. During that time, countless factors can deflect the projectile by millimeters that turn into meters of error over that distance. Ukrainian snipers have developed an integrated system that combines top-of-the-line equipment with intensive training. Drones equipped with high-definition cameras and atmospheric sensors circle the operational area, collecting precise meteorological data. These devices measure wind speed and direction at multiple altitudes, temperature, barometric pressure, and even the Earth's rotation, known as the Coriolis effect, which affects long-distance projectiles. All this information feeds AI systems that perform complex ballistic calculations in fractions of a second. The software takes into account the exact weight of the ammo, the wear on the rifle barrel, the altitude of both the shooter and the target, and dozens of other variables. The result is a firing solution that exponentially increases the odds of a hit. But here's something crucial that separates success from failure. Even with all that tech, the human factor remains indispensable. The shooter must control their breathing, sync the trigger pull between heartbeats, and make microscopic adjustments based on experience and intuition. Technology provides the data, but the human executes the shot. While Ukrainians were perfecting their long-range tactics, Russian forces faced a growing problem. their armored convoys had become easy targets for swarms of FPV drones. The response they came up with was as unexpected as it was controversial among military experts: massive use of motorcycles in combat operations. According to an international CNN report published in April 2025, Russia's military command began deploying small motorcycle-mounted squads for rapid movement through combat zones. The logic is simple: motorcycles are smaller, faster, and harder to hit than slow-moving armored trucks rolling down cratered roads. These motorized units, typically composed of 3 to 5 soldiers, carry out reconnaissance, supply runs, and even fast raids on fortified positions. Speed is their main defense. A motorcycle racing across open terrain at 80 or 90 kilometers per hour is a serious challenge even for experienced FPV drone operators. But Ukrainians quickly adapted their tactics to counter this new threat. The Security Service of Ukraine, known as the SBU, released in June 2025 some stunning footage showing their countermeasures in action. The videos show FPV drones chasing motorcycles at high speed across open fields, adjusting their trajectory in real time as the riders attempt desperate evasive maneuvers. The numbers are striking. According to official SBU data, more than 860 Russian troops were neutralized through drone operations conducted by the Special Operations Center designated by the letter A. These aren't estimates or projections, they're confirmed figures from operations documented on video. June 2025 marked one of the boldest moments of the conflict, Operation Spiderweb. This covert mission, carried out by Ukraine's security service, proved that drone technology isn't just for tactical combat on the front lines, it can also hit strategic targets hundreds of kilometers deep inside enemy territory. On June 1st, 117 FPV drones were smuggled into Russia, hidden inside regular commercial trucks. These devices were then launched in a coordinated strike against Russian air bases located extremely far from the Ukrainian border. The targeted installations included the Olenyo Air Base on the Kola Peninsula near Murmansk and the Belia Base in the Irkutsk region, a staggering 5,500 kilometers east of Ukraine. What makes this operation particularly significant isn't just the distance covered, but the chosen targets. Ukrainian forces managed to hit strategic aircraft, including A-50U mainstay early warning planes, extremely valuable assets that are hard to replace in Russia's air fleet. These planes, equipped with powerful radar systems, are crucial for detecting aerial threats and coordinating defensive operations. Each one destroyed represents not just a massive material loss, but a major gap in Russia's air defense capabilities. The operation demonstrated the principles of asymmetric warfare in their purest form. While each FPV drone costs only a few $100s to make, the targets they destroyed are worth tens of millions apiece. This cost imbalance has completely reshaped the strategic logic of the conflict. Experts from the Center for Strategic and International Studies, SISE, based in Washington, analyzed Operation Spiderweb and reached a chilling conclusion for conventional militaries worldwide. Unconventional aerial warfare is now possible, not just by land or sea. Small groups of operators can infiltrate drones deep into enemy territory and carry out precision strikes on critical military infrastructure without ever physically crossing the border. To understand why FPV drones have become so dominant, we need to look at what makes them unique. FPV stands for first-person view. The operator uses special goggles that show exactly what the drone's camera sees, creating the sensation of flying the aircraft firsthand. These devices are surprisingly simple in basic design. A modified commercial quadcopter, a video camera, a signal transmission system, and an explosive payload that can range from a few hundred grams to several kilos. The total cost of production rarely exceeds $500, making them naturally disposable. But their true power lies in how they're used. Unlike guided missiles or artillery, shells that follow predictable ballistic paths, an FPV drone can instantly change direction, chase moving targets, and even hide behind obstacles before making its final attack run. That flexibility makes them extremely hard to intercept. An international volunteer who served for 6 months on an FPV drone team in the Donbass region shared his experience in an article published in July 2025. According to his account, despite all the tactical advantages, operating these devices in real combat presents serious challenges rarely shown in the spectacular footage shared online. Electronic interference poses the biggest obstacle for FPV drone operators. Russian forces have developed sophisticated electronic warfare systems capable of jamming control signals, causing drones to lose connection and drop dead midair. On top of that, limited batteries only allow 15 to 20 minutes of flight, severely restricting their effective range. Even so, production numbers keep climbing. Ukraine has set a goal of producing over 1 million FPV drones during 2025. This mass production has turned what was once an experimental weapon at the start of the war into a standard tool present in practically every combat operation today. Beyond the record-breaking distances and deep strategic operations, the day-to-day reality of the conflict is full of engagements where drones and snipers make an immediate tactical difference. One case documented on video shows a Ukrainian sniper disabling the steering system of a Russian armored vehicle from a distance of 1,700 meters. This kind of extreme precision shot serves a very specific tactical purpose. By damaging critical components of armored vehicles without necessarily destroying them completely, snipers force crews to abandon their equipment, which can then be captured or destroyed later. A well-placed shot to the steering, transmission, or fuel system can immobilize a tank that cost millions of dollars to build. FPV drones have also proven to be far more versatile than just direct attack tools. Footage released by the Ukrainian army in September 2025 shows an FPV drone stopping a Russian assault by placing a TM-62 anti-tank mine directly in the path of an approaching armored vehicle. Instead of attacking the vehicle head-on, the drone simply positioned the explosive in the right place at the right time, showing how these tools can be used in creative ways their original designers never imagined. Perhaps the most unusual incident recently documented happened in early October 2025 when Ukrainian drones attacked a Russian patrol on horseback near Donetsk. Yes, soldiers literally riding horses. This surreal encounter between 19th century cavalry and 21st century drones illustrates the chaotic and unpredictable nature of modern warfare, where conventional tactics and technological innovation coexist in sometimes absurd ways. While images of drones chasing targets and extreme precision shots dominate the headlines, there's a parallel conflict going on that remains largely invisible to casual observers: the competition between drone control systems and electronic countermeasures. Russian forces have heavily invested in electronic warfare, developing equipment capable of detecting the radio frequency signals used to control drones and then jamming or distorting them. When effective, these systems can create protection bubbles where drones simply can't operate. They drop from the sky as soon as they enter the affected zone. Ukraine's response has come through multiple innovations. Some drones now use constantly changing variable frequencies, making them much harder to jam. Others employ inertial navigation systems that allow them to keep flying even after losing their control signal, following pre-programmed coordinates right up until the moment of impact. Perhaps the most impressive innovation is the use of drones connected via fiber optics. Reports from October 2025 reveal that Russian forces are now deploying FPV drones that maintain a physical connection to their control station through an ultra-thin fiber optic cable that unspools as the drone flies forward. This cable is virtually impossible to intercept or jam electronically, making these drones immune to traditional electronic warfare. Ukraine has already begun developing countermeasures for this new threat, part of an endless cycle of innovation and counter-innovation. The effects of these new tactics go far beyond immediate battlefield results. They're fundamentally reshaping how military strategists around the world think about future conflicts. The economics overwhelmingly favor drones. A single modern tank can cost between $5 and $10 million. An FPV drone costs $500. Even factoring in that several drones may be needed to guarantee a hit, the cost-benefit ratio remains absurdly in favor of drone attacks. This equation completely flips the traditional military power model built around heavy equipment. On top of that, the entry barrier for drone production is incredibly low. While tanks, aircraft, and modern artillery systems require sophisticated industries, years of development, and billions in investment, FPV drones can be assembled in small workshops using commercially available components. This democratizes military capability in a way few people ever anticipated. Smaller nations, non-state groups, and defense forces with limited budgets now have access to capabilities that were once exclusive to military superpowers. This shift carries deep implications for global stability and for how future wars will be fought. Despite all these advantages, it's important to understand that FPV drones and long-range sniper tactics aren't magical solutions that solve every military challenge. Both tools have major limitations that are often underestimated in surface-level analyses. FPV drones depend fundamentally on visibility. In conditions of dense fog, storms, or total darkness, their effectiveness drops drastically. cameras, no matter how advanced, still need enough light to produce usable images. Night vision systems help, but they add weight and cost, reducing flight time and increasing the price of each unit. Operator training is also a serious bottleneck. Flying an FPV drone in real combat, under stress, with a moving target trying to evade and enemy defenses try to shoot you down, requires skills that take months to master. It's not just like playing a video game. It's making life or death decisions in fractions of a second with equipment that could fail at any moment. For snipers, the limitations are even tougher. Each long-range shot requires extensive preparation, scouting the area, setting up a secure position, configuring equipment, and waiting for the perfect window of opportunity. A sniper might spend days in position just for a few seconds to take one single shot. If they miss, their position is compromised, and the chance probably won't come again. Amid all this talk about technology, artificial intelligence, and tactical innovation, one element remains absolutely central: the human factor. Behind every drone is an operator making decisions. Behind every precision shot is an individual with years of training and experience. FPV drone operators often describe the experience as surreal and psychologically challenging. They see their targets in intimate detail through high-definition cameras. They watch reactions, escape attempts, facial expressions in the final seconds. Before impact, this visual closeness combined with physical distance creates a cognitive dissonance that can be deeply unsettling. Snipers face different but equally intense psychological challenges. The long waits, the pressure of knowing one mistake wastes a once-in-a-lifetime opportunity, the awareness that their shot might save allied lives or fail at the critical moment, all create an extraordinary mental burden. Both roles require not only exceptional technical skill, but also psychological resilience and ethical decision-making under extreme conditions. The best operators aren't necessarily the ones with the sharpest reflexes or most accurate aim. They are the ones who can maintain mental clarity and moral judgment even when everything around them is chaos and destruction. What we're witnessing on the battlefields of Eastern Europe represents far more than just another chapter in military history. We're watching the emergence of a new era, one where accessible technology, skilled operators, and innovative tactics combine to create capabilities that were once exclusive to superpowers with defense budgets in the hundreds of billions. Snipers breaking world records with AI-assisted shots from 4 kilometers away. FPV drones costing a few $100s, destroying multi-million-dollar equipment. Clandestine operations infiltrating swarms of drones hundreds of kilometers into enemy territory to hit strategic targets. All these realities show that military power in the 21st century will be fundamentally different from what it used to be. The implications go far beyond the current conflict. Every nation with armed forces must now rethink its doctrines, investments, and strategies in light of these new realities. Equipment that took decades to develop may become obsolete in the face of threats that can be built in months at a fraction of the cost. But perhaps the most important lesson is this: in a world where military technology is rapidly democratizing, where devastating capabilities are becoming increasingly accessible, the need for diplomacy, dialogue, and peaceful conflict resolution becomes even more urgent. Because in a future where anyone can cause massive destruction, the only true victory is the one where the fight never begins. The innovations we're witnessing in Ukraine aren't just about how to win the next battle. They're about how the very nature of conflict is changing, and why finding ways to prevent these confrontations has become more crucial than ever in human history.